Hello everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the first part. In this part, we're supposed to determine the type of case given the equation of an ellipse, the coordinate of the center, the coordinate of the foci, vertices, and the co-vertices, and we're supposed to sketch the graph of this ellipse. Before we go over this example, let's have a review on the parts and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the a will be under the x. Now, we also remember that the value for a is always greater than b. And the equation that relates a, b, and c is c squared equals a squared minus b squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is h comma k plus minus c. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths a, b, and c is c squared equals a squared minus b squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, so let's go back to the problem here. In order that we can fill this in and sketch the graph of this ellipse, we look at the denominator, and we remember that the value of a squared is always bigger than b squared. So we can go ahead and say that this 49 right here is our a squared. So I'm just going to go ahead and label that up here. So this is our a squared, and this 25 is our b squared. So I labeled it. Now, since our a squared is under the x, we can go ahead and say that this is an example of a horizontal ellipse. So I'm going to go ahead and write that down here. Okay, from here, we can go ahead and say that since our a squared is 49, so I'm going to write that up here, a squared is 49. We can therefore say that our a is the square root of 49, so that would be a plus minus 7. And since we say that our b squared is 25, so b squared is equal to 25. So if we wanted to solve for b, we get the square root of 25, so that is plus minus 5. Now, we also remember that the HK represents the center of this ellipse. So in this case right here, we have this HK. So in order that we can write the center of the ellipse, we remember that we are supposed to switch and switch, meaning whatever the sign is, you switch it. Whatever the sign is, you switch it. So the center for this ellipse is, since this is a plus 3, so that's a negative 3. And since this is a minus 4, that is a positive 4. So I go ahead and plot this center right here. So that is negative 3 and 4. So this is our center. So I'm going to label this as letter C. And we say that our A is plus minus 7. Remember that A is the distance from the center to the vertex. And since we say this is a horizontal ellipse, so I go ahead and do 7 steps to the left and 7 steps to the right to determine the two vertices. So that would be 1, 2, 3, 4, 5, 6, 7. So this is the first vertex, and the other vertex is on the other side across. 1, 2, 3, 4, 5, 6, 7. So this is the other vertex. So that we can go ahead and write the coordinates of these two vertices up here. Okay, now let's plot the co-vertices. Now we remember that the distance from the co-vertex to the center is represented as letter B. So I go up 5 and down 5 to determine the co-vertex. So that's 1, 2, 3, 4, 5. This would be 1, 2, 3, 4, 5. And so I'm going to label this as the co-vertex, and this is our co-vertex. So that I will write the coordinates of these two co-vertices up here. So I'm now ready to sketch the ellipse. Okay, we need to determine the coordinates of the two foci. So we are given A and B, and we remember that our foci should be located on the major axis. It should be located along this line segment. And so we remember that the distance from the center to the foci is represented as letter C. And we can solve for C using the equation C squared equals A squared minus B squared. So I'm going to go ahead and write that up here. So I will plug in the value for A squared, which is 49, minus the B squared is 25. So we are able to get a C squared of 49 minus 25 is 24. So we go ahead and get the square root for both sides to solve for C. So this comes out C is equal to plus minus square root of 24. We can reduce this. 24 can be factored out, this is actually c is equal to plus minus square root of 4 times 6, and the square root of 4 is 2, and square root of 6 is square root of 6, so we can go ahead and say that our c is 2 square root of 6. That's a plus minus, or this is approximately gonna be equal to 4.9. This means that I go 4.9 steps to the left and 4.9 steps to the right to determine the location of the two foci. Okay, so we're supposed to write the coordinates of these two foci. Since this is a horizontal ellipse, we remember that the coordinate for the two foci of a horizontal ellipse is h plus c comma k and h minus c comma k. So it's pretty much the same thing as the center, but this time around we are supposed to plus and minus this value for c on the h value. So that means the coordinate for the two foci would be -3. I write -3, and then I will have to plus this, so plus 2 square root of 6, and the k value is 4. And the other coordinate of the foci is -3. I will minus the 2 square root of 6 and then 4. So we pretty much have the same value, -3 and 4, -3 and 4. However, since this is horizontal ellipse, we're adding the c and subtracting the c to the h. So this is the coordinate of the two foci. Now, we determine the length of the major axis. That means the length from the vertex to the other vertex here. And the length of the minor axis. That is from the co-vertex to the other co-vertex. So I'm going to go ahead and write that down here. Now we remember that the length of the major axis, this is this one right here. We say that the length from from the center to the vertex is A, and so the length of the major axis is 2A. So I'm gonna go ahead and write as 2A right here, and that is actually equal to, since our A is 7, 2 times 7 is 14, and the length of the minor axis would be the distance from the center, the co-vertex, is represented as letter B. And so if we say minor axis, that's doubling it. So that would be 2B. So this is 2B right here. Since our B is 5, we can go ahead and say that the length of the minor axis is 10. So these are the values for the length of the major axis and the minor axis for this ellipse. We can go ahead and count it to see if they match up. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14, and this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 10. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're supposed to determine what is the A and what is the B for this. Now we remember that the A squared is always bigger than the B squared. This tells us that this is our A squared and this is our B squared. So I'm gonna go ahead and label this as our A squared, and this will be our B squared. And so we are going to solve for A and B. Okay, so we've determined the values for A and B from here. And so we can go ahead and say that since our A squared is under the Y is up and down. So this is an example of a vertical ellipse. So I'm going to go ahead and write it down here. Now we determine the center. Now we remember that the center is HK. Remember, we're going to switch and switch. So this tells us that our center is located at, since this is -1, so that would be 1. And this is a +3, that's a -3. So what I would do is I will plot this center down here. So that is on 1 and then -3. So it should be somewhere down here. So this is our center. Now, our A is plus minus 6. So since this is a vertical ellipse, I go up 6 and down 6. And since our b value is 4, so I go left 4, right 4. So I'm going to go ahead and plot those 4 points here. Okay, so I've drawn the ellipse down here. Now we're supposed to determine the foci or the coordinates of the two foci. Now we remember that the two foci are located c distance from the center. So I'm going to go ahead and solve for c using the equation c squared equals a squared minus b squared. So I'm going to show the work down here. Okay, our value for C is 4.47. This is a plus minus, and so we are going to go up 4.7 and down 4.47. So that would be 4.47. 1, 2, 3, 4.47 should be somewhere around here. So this is our first focus, and the other focus would be 4.47 down from the center. 1, 2, 3, 4.47, and this is the other focus. So we can go ahead and say that since this is a vertical ellipse, the coordinates of the focus would be h comma k plus c and h comma k minus c. So it's pretty much, we rewrite the whole thing here, but since this is a vertical ellipse, we are going to add and subtract the c from the k value. So this comes out, that would be, we just copy the first one, so that is 1 comma negative 3 plus this one plus 2 square root of 5, and the other is, we subtract it, 1 negative 3 minus 2 square root of 5. So these are the coordinates of the two foci. Now let's determine the length of the major axis and the length of the minor axis. I'm going to go ahead and write it down here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!